Good evening, students. Today, let us explore the controller tuning method, which is the first method called as the Ziegler-Nichols method. So here the Ziegler-Nichols method, there are two methods of tuning method. One is a Ziegler-Nichols 1 method, another one is a Ziegler-Nichols 2 method, which is open loop and closed loop respectively. Okay, so here we want to choose the settings of the controller. Okay, so controller, you know very well, already we have explored during the composite and continuous mode of controller. There are proportional plus integral plus derivative term. It is called as a three-term controller. Okay, so here coming to this already we explored proportional controller. It is mainly used to see the current value of the error signal, integral past value, and derivative future value of the error signal. Okay, so this is a relationship of input output, a relationship of PID controller. Okay, so coming to this Okay, so coming to the first method is called as a Ziegler-Nichols method, which is also called as a open loop method. Okay, so in open loop, we are going to have only a plant. We are going to excite the plant with a step input. You will be getting a step response. We call this as a S-shaped response. Okay, from the step response, we are going to determine the two parameter. One is a delay time, another one is a time constant. Let us represent that as L and T. Okay, so from this S-shaped curve. Here we will compute what is the value of gain, what is the delay time, and what is the time constant. Okay, so for when you take a process gain, it is nothing but the maximum value of where it is settling, that is called as a process gain. And similarly, you know very well, delay time is a time taken by the responsive system to respond to the given input, that is L. And to determine the time constant, we are going to draw a tangent line to the S-shaped curve and see where the tangent line meet the and draw the line where it meets the time scale and after the delay time and where it is reaching. Okay, that respective time is called as a time constant. Okay, so here is a tuning rule proposed by Ziegler and Nichols. Okay, for a proportional control, for proportional plus integral, for proportional plus integral plus derivative control. Okay, so the respective controller settings. Okay, so we know very well already KP, it's not KP, it is KC, tau I and tau D, TI and TD. Okay, so here T stands for time constant, K stands for gain, and L stands for delay time. Okay, so using this tuning rule proposed by Ziegler-Nichols, we are going to design the PID controller. Okay, next, let us see one example representing this open loop method. Okay, so here there is a open loop response is given, S-shaped curve is given. From this S-shaped curve, one can find out what is the delay time, time constant, and gain. Okay, so knowing these values, using the open loop Ziegler-Nichols setting, one can determine the controller settings. Okay, so let us take an example to represent the open loop step response of the thermal system. Okay, so obtain the transfer function of the system. Use the Ziegler-Nichols tuning method to design the proportional control, proportional integral, and proportional integral plus derivative control. Draw the block diagram of the system in each case. Okay, so here the open loop response is given. The response starts at 10 degrees Celsius and reaches 50 degrees Celsius. So K value is 40, and delay time it is represented as 5, and time constant it is given as 20. Okay, so knowing these parameters and using the tuning rule proposed by Ziegler-Nichols, one can design the controller. So first, initially you have to determine the transfer function of the plant, and knowing the transfer function with all the parameter settings, one can design what is a proportional controller and its respective transfer function. And similarly, you take a proportional plus integral controller, and finally proportional plus integral plus derivative control. Okay, coming to the second method, which is called as a Ziegler-Nichols closed loop method. It is called the closed loop method. So what we are going to do is, we are going to take only a proportional control alone, keeping integral time constant and derivative time constant as infinity and 0. Increase the value of Kp until the step response of closed loop system reaches a sustained oscillation. So from the sustained oscillations, one can find out what is the value of ultimate gain and ultimate period. So ultimate gain is nothing but the critical value of the gain value Kp, and ultimate period is one cycle of oscillation. What is the respective period? Okay, so this is a block diagram of the second loop closed loop method. Okay, so here knowing the value of Ku and Pu, that is ultimate gain and ultimate, you call the ultimate gain or a critical gain, and ultimate period or a critical period. So one using this controller setting, one can design the controller using the second method of tuning.